Hello students, how are you? Hope you are doing well. Now the question is a case study based question and the topic on which it is based is motion of charge in magnetic field. So an electron with speed v naught very less than c moves in a circle of radius r naught in a uniform magnetic field. This electron is able to traverse a circular path as the magnetic force acting on the electron is perpendicular to both v naught and b as shown in this particular figure. This force continuously deflects the particle sideways without changing its speed, and the particle will move along a circle perpendicular to the field. The time required for one revolution of the electron is t naught. So this is the basically paragraph of the case study, and this is the corresponding figure. So these are the questions based on the case study. The first question is, if the speed of the electron is now doubled to v naught, the radius of the circle will change too. So in this particular question, the speed of the electron is increased. So the question, according to the case study, there is a magnetic field like this going into the plane of the board. The charged particle, that is electron, is moving in a circular path with a fixed speed of v naught. Now its speed is increased from v naught to 2v naught. Then what is the effect on the radius? So for it, we have to know the radius of the circular path. The radius of circular path is given by r equals to mv upon qb. This is the formula to calculate the radius of the circular path moving in a uniform magnetic field. So now in this particular expression, we can clearly see that the radius is directly proportional to v, because the magnetic field is constant, means uniform, the charge is fixed, the mass is fixed, so we can say that r is directly proportional to v. So if we double the velocity, then the radius will also be doubled. So we can say that option B is correct here. It is new radius is 2r0. So this is the second question is, if v equals to 2v0, then the time required for one revolution of electron t0 will change to option A 4t0, option B 2t0, option C t0, and option D t0 by 2. So in this particular problem, if the velocity is increased 2 times, then we have to find out the change in the time period. So for this particular part, we have to know the expression for the time period of the revolution of a charged particle moving in a uniform magnetic field. It is 2 pi m upon qb. You can clearly see from this expression that it does not depend upon the speed of the particle. It only depends upon the mass, the charge, and the magnetic field. And 2 and pi are also constant. So we can say that the time period does not depend upon the change in speed. So we can say that there is no change in the time period in this particular case, because the particle is same, mass is same, charge is same, and the magnetic field is same. So we can say that the time period is t naught. So this is the answer of this particular second part of the problem. Now the third part of this problem is, a charged particle is projected in a magnetic field B equals to 2i plus 4j into 10 raised to the power 2 Tesla. The acceleration of the particle is found to be a equals to xi cap plus 2j cap meter per second square. Find the value of x, and the given options are 4 meter per second square, minus 4 meter per second square, minus 2 meter per second square, and plus 2 meter per second square. So the basic concept here is this particular expression F, which is the force acting on the particle, is mass times acceleration, is equal to q v cross b. So from this particular expression, we can clearly see that the direction of A is perpendicular to both v and b. It means that A is perpendicular to b, and if A is perpendicular to b, then its dot product with b should be 0. So we can say that the dot product of acceleration, which is given as xi cap plus 2j cap, with the magnetic field, which is given as 2i plus 4j 10 to the power 2, this should be equal to 0. So after solving it, we get this. After solving it, this comes out to be 2x plus 8 equals to 0. It implies that x equals to minus 4. So the value of x is minus 4. So we can say that option B is correct here. So I'm telling this, I'm explaining this particular problem in Hindi also. एक चार्ज पार्टिकल है, प्रोजेक्ट किया गया है मैग्नेटिक फील्ड में, जिसकी वैल्यू दे रखी है 2i + 4j टू 10⁻² टेस्ला। एक्सेलरेशन दिया पार्टिकल का इक्वल्स टू xi कैप + 2j कैप मीटर पर सेकंड स्क्वायर। हमें बताना है x की वैल्यू क्या होगी। तो उसके लिए हमारे पास एक्सप्रेशन है फोर्स का। फोर्स का एक्सप्रेशन होता है मास टाइम्स एक्सेलरेशन अकॉर्डिंग टू न्यूटन सेकंड लॉ ऑफ मोशन। एंड मैग्नेटिक फोर्स का एक फॉर्मूला होता है q v क्रॉस p। अब वेक्टर क्रॉस प्रोडक्ट के रूल के हिसाब से यानी v क्रॉस b की जो डायरेक्शन है वो डायरेक्शन a की डायरेक्शन कहलाएगी, या हम कहें a की डायरेक्शन परपेंडिकुलर है b की डायरेक्शन से। और अगर दो वेक्टर परपेंडिकुलर हैं एक दूसरे के तो उनका डॉट प्रोडक्ट होगा जीरो। तो हमने दोनों पार्टिकुलर वेक्टर्स बी वेक्टर और ए वेक्टर के डॉट प्रोडक्ट को जीरो के बराबर रख के इसे सॉल्व किया तो एक्स की वैल्यू हमारी -4 निकल के आती है। सो ये सॉल्यूशन हुआ इस पर्टिकुलर प्रॉब्लम का। नाउ द नेक्स्ट प्रॉब्लम, फोर्थ पार्ट ऑफ दिस प्रॉब्लम। If the given electron has a velocity not perpendicular to b, then the trajectory of the electron is a straight line, circular, helical, or zigzag. So, in this particular problem, it is said that velocity is not perpendicular. In the case of perpendicular between the velocity and b, the magnetic field, the direction is a circular direction. But if the particle enters the magnetic field with a velocity having a certain angle with velocity, not perpendicular to it. Velocity is making an angle of certain angle of not equal to 90 degree with b. Then in this particular case, there are two situations. First situation is, suppose this is the angle, this is some acute angle, not 0 and not 90 degree. So in this particular case, the particle moves in a helical path. The particle moves in a helical path. But suppose if the velocity vector is making an angle of 0 with the b, then in this case the helical path possibility is not there. So accordingly we can say that the particle is making a certain angle with b, not a zero angle. So the answer is helical path. Now I am explaining it in Hindi also. अगर पार्टिकल की वेलोसिटी परपेंडिकुलर नहीं है बी के, यानी कोई एक सर्टेन एंगल है जो कि 90 डिग्री नहीं है, तो उसकी ट्रेजेक्टरी क्या होगी। तब इस कंडीशन में ट्रेजेक्टरी हमेशा हेलिकल पाथ होती है। एक पर्टिकुलर कंपोनेंट वेलोसिटी का इसको आगे शिफ्ट करता है और एक इसे सर्कुलर पाथ में मूव कराता है, जिससे कि ये हेलिकल पाथ में मूव करेगा। नाउ द ऑप्शनल पार्ट ऑफ द fourth subpart is, if the electron of the charge E is moving parallel to the uniform magnetic field with a constant velocity v, the force acting on the electron is, and the given options are BeV, Be upon V, B upon Ev, and 0. So in this particular problem, the direction of the velocity of electron is along the magnetic field. So we can say that there is an angle of 0 degree, and we can say that the cross product of V cross B is become 0. So the force in this case acting on the electron is 0. So certainly the option is D. इस पर्टिकुलर प्रॉब्लम में बताया गया है कि इलेक्ट्रॉन जो है वो पैरेलल मूव कर रहा है मैग्नेटिक फील्ड के। तो अगर पैरेलल मूव कर रहा है इसका मतलब वी वेक्टर और बी वेक्टर के बीच में एंगल 0 होगा, और अगर एंगल 0 होगा तो साइन ऑफ 0 की वैल्यू हमारी 0 होती है, जिससे कि क्यू वी क्रॉस बी 0 हो जाएगा। इट मीन्स दैट फोर्स 0 हो जाएगा। सो द आंसर ऑप्शन इज 0, which is correct. Option D is correct here, which is 0. Hope you understand the solution. Thank you.